So in the spirit of Easter, and because football draft is this Thursday and Friday for the NFL, I have this football egg, and I have a football algebra 2 question. So that's all for that. There it goes. Basically, we're going to get our classic parabola, and we're going to have a not equal 1. And what that means is in our parabola, you don't have a regular t squared or x squared in the front, right? You're going to have, get a good color. Oh, that's way too big. We're going to have negative 16 be our a value. And that is the coefficient before that first term, okay, the t squared term. Hopefully you guys know by looking at this throughout Algebra 1 and Algebra 2, you know that that is in the shape of a parabola. We know a few things about it. That negative a term means the parabola is going to open down. So if you were to draw a quick sketch of that parabola, it would look something like this. Too big. It looked like this. The parabola opens downward, and you would go into the negative territory. Okay. Now, part A asks, what is the appropriate domain for this function in the context of the football's flight? Okay, well, let's see what the football is doing. It's kicked into the air, and its height h of t in feet after t seconds is modeled by this equation. So what is the equation? It is, is negative 16t squared plus 64t plus 36. Actually, I'm not going to circle that so that we don't have errors come up. Okay. Again, it looks something like that. Now, we know a few things. Okay, first of all, they're asking domain. Think about, are we looking for the possible x values or the possible y values based on the word domain? They want to know all the possible x values, okay? All possible y values would be the range, okay? Now, what's interesting is technically this parabola could go into the negatives right here, but it doesn't for the simple reason the negatives would represent the time before the football is kicked, okay? If you think of your little guy kicking your football right here, and for some reason he's floating, but we'll get to that. The domain that you're going to use is starting at time 0 and going to infinity. Now, what that would look like is this, okay? Closed bracket here, we go up to infinity. However, technically that parabola is going to shoot through the floor. We don't totally care about the ball, potentially going through the bottom of the football field. So technically that goes up through infinity, but you could argue that it does stop when it hits the football field. Okay, so the appropriate domain, though, you would say are all positive rational numbers. And all that means is that we're not just looking at integers, we're looking at any, or no, not even rational. We're looking at all positive real numbers, right? Because rational would mean that you can have numbers that can be written as a fraction, right, of one whole number divided by another whole number. But we can also include the irrational numbers, right? All positive real numbers, specifically. All positive real numbers. And what time is the football 36 feet above the ground? Okay, so interesting part of the question. You'll notice that plus 36, hey, that is the y-intercept. What does that mean? That means if we plug in 0 into t, you should automatically know what are we going to get as our height of 0. You are going to get 36, okay? So this is where we get into the floating, okay? Normally, picture in this question, you've got your little guy, okay, kicking the football field. He's actually going to kick this football on a ledge into the sky, okay? He's kicking it off of a ledge for some reason, 36 feet up. You can imagine it like going into a pool or something. I don't know. But just because of the way this parabola works out, he's starting at 36 feet high. So you can imagine the height of this ledge equals 36 feet. just based on the way the parabola is set up. Honestly, I designed this parabola just so that the numbers work out nicely. So that's why we've got a 36-foot high guy kicking a football. But you have to know that in a parabola, if you start at 36 feet high and you go up, you're going to go down and it's going to pass 36 feet again. So what does that mean? Well, let's take a look at our function. We've got, I'm going to do some of the math up here. Over negative 16t squared plus 64t plus 36 equals what? We want to set this function equal to 36. Now what? Well, we want to get t by itself. So minus 36 minus 36. We're going to get 0 on the right. And on the left, we're going to have negative 16t squared plus 64t. Oh, that's working out conveniently. We can factor out a t. And more than that, we can factor out a 16t. Okay? You factor out 16t or negative 16t. Doesn't really matter which. In this case, we will factor out, because we'll just factor out a regular 16t. Okay, and what you're going to end up with is negative t plus 4. Because remember, when you factor something, you're dividing each of the terms by that thing that you factor out, which in this case is 16t. Now, what can t equal? You set both of these equal to 0. So if 16t equals 0, that means that t is going to equal 0. And if negative t plus 4 equals 0, we can add t to each sign. We're going to get t equals 4. So our two options are that t equals 0 or t equals 4, which means that in 4 seconds, the football is going to launch up, and then it's going to fall back and zoom past that 36-foot height that it started at. And you've got your guy that hits the ledge. We can keep adding to our picture here. This is the 36-foot mark. This will happen at t equals 4. And I don't know why he's kicking it off a ledge, but or you can picture the guy's a big giant, and the football starts at a height of 36 feet. Okay, but the point is that 36 feet has to represent the starting height of the football, meaning the guy did not start from the very ground. He started from a ledge somewhere. Okay, what is the maximum height? Okay, when you're finding maximum heights, do a little bit of labeling here. This is part B. This is A. This is a picture. Let's get into part C. Vertex formula. Okay. So, part C. So the vertex formula, what is that? The vertex is going to be negative b over 2a. What that means is when this function, okay, when we take the b value of this function and the a value of this function and plug them into this formula, you're going to get the x value that represents the maximum height of the parabola. Okay, so we'll say the x value we want equals that negative b over 2a, and just plug it in. Okay, negative b over 2a, so that's going to be negative 64 over 2 times negative 16. Guess what that simplifies to? 2. So that means the x value is going to be 2. By the way, a vertex can be the maximum and it can be the minimum. What that depends on is, does your parabola open downward because there's a negative a value, right? That's what this is. Or does it open upward? And then it would be the bottom, the minimum. Okay? That is not what this is. Since the a value is negative, it opens downward, and the maximum is going to be represented by the vertex. So where x equals 2, that should be the maximum of the function. We're just going to plug in h of 2 equals negative 16 times 2 squared plus 64 times 2 plus 36. Simplify each term. Negative, that's going to be 16 times 4, which is going to be negative 64 plus 128 plus 36. And that's going to give you 164 when you add those two together. Minus 64 is going to give you 100. What does that mean? That means that the tip of this parabola, let's go back to our little picture here. Okay. Also right here. This is going to be represented like colors to the point 200. Okay, what does that mean? That means after 2 seconds, that ball is going to be 100 feet tall. He started 36 feet because he's on a ledge somewhere, kicks it up into the sky. It starts to turn around at 2 seconds where it's 100 feet tall, and then it starts to come back down. Hold on, it's going to turn me off. Okay, so now what do? Last thing we need to find when the football will hit the ground. This is where it gets kind of fun, okay? So you can do this one of two ways. Negative 16t squared plus 64t plus 36. Let's copy it down again. Good color. We'll just do blue. Negative 16t squared plus 64t plus 36. If you want to know when the ball hits the ground, and the h of t represents the height of the ball, think about what the height would have to be when it hits the ground. 0, right? The height would have to be 0, meaning this whole function we want to set equal to 0. So now what do? We take this function and we factor it. Now, alternatively, by the way, it doesn't want you to factor it. It actually just wants to know the time which it hits the ground. And for that, that's what you get to use. Negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And guess what that is? The quadratic formula. So yes, you could use a quadratic formula. Yes, we can plug that in, and we can get the time that it's going to take to hit the ground. I'm going to use this as an opportunity to practice some of that more advanced factoring, where we have an a value that is not equal to 1. Okay, so here's how I would approach factoring this. First, look for, so this is, by the way, this is the one way that you could solve it. This is another way. Okay, one thing we can do here, factor out what is our greatest common factor we can pull out. Yes, there is. Either 4 or negative 4. I'm going to pull out negative 4 this time so that I get a positive a value. I want to work with a positive a value. It is up to you, again, but I think positive a values are nice. Okay, and all that means is that I'm going to divide each of these terms by negative 4. Okay, so the first one, negative 16t squared divided by negative 4, it's going to give you positive now. It's going to still be t squared plus 64t divided by negative 4. Addition right plus, because that's going to turn into a negative 16t. And then 36 divided by negative 4, that's going to turn into a negative 9, which shows up as a minus 9. Remember, when we talk about terms, we talk about them as positive or negative. But then when you group them together, you write it as addition or subtraction. So that's what's happening here. So the next thing we want to do is, again, we want to find our two special numbers, right? And it just gets a little more complicated when we've got an a value that isn't 1. So we have to find that special a times c value. That's going to help us group this properly. So a times c, meaning, okay, let's take our 4, let's take our negative 9 and multiply them together. 4 times negative 9, that's going to give you negative 36. Meaning, okay, I need two numbers that multiply to negative 36, and we want them to add. I'm going to write multiply here, or just mult. And then we want it to add up to negative 16. So brainstorm for a second. I actually encourage you to pause the video for this part, because I want you to know how to find these two numbers. We want two numbers that multiply to negative 36 and add up to negative 16. Okay, so you've paused, right? Paused and found those two numbers. Don't be lazy. Okay, what are they? Negative 18 and positive 2, right? Because negative 18 times 2 is negative 36. Negative 18 plus 2 is going to give you negative 16. So here's what we do. Keep the negative 4 here. And then on the inside, we are going to do a little bit of grouping. We're going to write out 4t squared plus, we'll do minus 18t, And it'll work out whether we do the minus 18 there or the plus 2 there, obviously with the t. It doesn't matter which way you do it. You'll end up with the same thing. They might be backwards, but that's okay. And by the way, if we didn't take a -4 out and we took a +4 out, you'd still end up getting numbers that multiply together correctly. Just trust me, it works. If you want to try that on your own, knock yourself out. So we have -18t, and it's going to be a plus 2t, and then a minus 9. And now these are nicely grouped because we can take out, it ends up being the same factor from each of these groups. N equal to 0. We have a -4 times what? Well, what can I take out of the first group? There's a 2t common factor. We have a 2t here times 2t, because 4t squared divided by 2t is 2t again. And -18t divided by 2t is -9. Plus, now we want to take out a 2t minus 9 from the second term. Look at that. We have what? It's just going to be +1, right? Because we take out the whole thing. So there's not really a second factor you could pull out of the second group, but we end up with that same 2t minus 9 in the second group. Okay. Again, this would work differently if you flipped around those second two terms. And just as a reminder, for those who are a little stuck, okay, that quadratic formula does work. And this question does not ask you to factor. It just asks you to find the solution. Quadratic formula would give you two answers, the same two answers we're going to get here. And we pick one, just like we're going to do here. Okay, but again, I'm not going to get into that. You can look at other videos for some quadratic formula practice. So -4 times what? Well, the 2t minus 9 is going to be one of our groups, and then it's going to be plus 2t plus 1. Right, that shouldn't be a plus. These are being multiplied together. 2t plus 1. We want to set that equal to 0. When we set these equal to 0, we set each group equal to 0. So if 2t minus 9 equals 0, that means 2t equals 9 divided by 2 divided by 2. We get t equals 4.5. We can now do this with our other group. 2t plus 1 equals 0. 2t equals -1 divided by 2 divided by 2. T also equals -0.5. But guess what? What did we say about the domain in the context of this question? We don't care about negative times because our parabola only models after the kickoff. Again, you could argue that our domain really could be from 0 to 4.5. Because what's going to happen when the football hits the ground? It's going to bounce up again. It's not really going to, act like the parabola. So if you were to really look at this graph on the part that we care about, look something like this. Okay? And you would just go from here, Okay. So that's the time, 4.5 seconds. Quadratic formula will give you the same two numbers, and we would still pick 4.5 seconds. Just so you can see what this graph looks like. Okay. This kind of confirms our work. -16x squared plus 64x plus 36. Up here, we have the vertex of 2, 100. Down here, we have where it hits the ground at 4.50. Here's our y-intercept of 0.36. Okay, so just as a review, y-intercept is where it hits the y-axis. The x-intercept is where it hits the x-axis, which would be at 4.5 seconds into the flight. Another word for that is zeros. Yes. And another word for that, can you think of it? Is roots. If you were told to find the roots of an equation, you'd be finding the zeros. Okay. Honestly, this question, stop sharing. This question, it's there are parts of Algebra 1 that are in here. Okay. Where we get into some of the a not being equal to 1 is some of the very Algebra 2 specific stuff. and just being really comfortable with that terminology. What is domain? What are they asking in that first question? Right? We don't care about negative times is really what we're trying to get at, because we don't care before the guy kicks the ball. We just care about the problem once he kicks the ball. Okay. So this is helpful. Please share it. Please like this. Comment. Tell me what video you want me to make next, because I'm trying to make as much as I can to help you guys. I am doing kind of a special offer. If you're in Algebra 2, going into pre-calc soon, take me up on that. It's a free hour of tutoring. You get one-on-one time with me. Yes, this is legit. And I will work with you one-on-one just with a free hour. And basically after that, I'll tell you more about what we do. We would decide if it makes sense to keep helping you after that, or if you kind of feel better after talking for a little bit. But yeah, you can send me whatever you want. We can take a look at it and see if I can help you out a little bit. But I hope this helped somebody. If it did, please let me know, because I like to know that. I don't want to make things that are not helpful. And I will see you guys in the next one.